Okay. This will be my second attempt. Okay. So, I think the reason that I was struggling so hard with this one is because I deliberately picked a point for one of the like chopper and happer spots that didn't hit like a pretty point. It's like in the middle somewhere, okay? And I think I made the mistake of starting with that point, and then it totally ruined my mojo. All right. Let's just go backwards. Can we start with F? I still have trauma with this side of the triangle, so we're going to start with F. We're going to plot our center P. It's at -5, -8. This is our P. Instead of starting with our lines that radiate out from our center through our image and pre-image points, we're going to use those at the end to double check ourselves so that we don't wreck ourselves. Okay, we'll just use those to like check our work. Yep, one-stop shop. Okay, so if I make a right triangle from point P, point F, all the way up, what is my change in my y going from P that's at -8 to F that's at +8? What am I having to add to go from -8 to +8? 16. Can you sit there and count them? Yes. But can you look at the axis and figure out it's 16? Also yes. Okay. My horizontal change in X is easier. It's just right 2. So if I think about point P as being like my fake origin, okay, you don't have to draw the whole axis, just think that that's your fake origin. Do you see that this is like right 2 up 16, okay? And we only want to go half of that distance. So we are going to do half of the X and half of the Y and land in the middle, okay? So half of 16 is 8. So we're going to do up 8 and then half of 2, 1. So we're going to go up 8, right 1, and that's going to be our F prime. So the actual coordinates of that point are -40. Okay, I think the weird one is point E, so we're going to save that one for last. Okay, let's do point D next. We're just going to jump around. Just pick one. Okay, we're going to do this dark blue. So I'm going to make another triangle. I'm going all the way out to 5, and then back up. Oops, I went too far. I went to 6. Okay. Guys, I'm saying triangle, but I'm not drawing the hypotenuse. Does everybody see that like there's a hypotenuse that's going like this? Okay, so I'm saying triangle, but I'm only drawing the legs of a right triangle. I'm not drawing the hypotenuse. Okay, so what is my change in X going from -5 to +5? 10. And then again from -8 all the way up to +8. 16 again. Thank you, math gods. So again, if I'm imagining that P is my fake origin, I don't want to go the full 10 to the right. I just want to go half of that. So I'm going to multiply my 10 by a half, or divide by 2. So I'm only going to do 5. And then instead of going the entire 16, I'm only going to do half of 16 and go up 8. So from my center of dilation, I'm doing 5 to the right, up 8. I have not labeled these points. This is D prime. My other one was F prime. The coordinates of D prime, it's the actual origin, 0, 0. Okay, this is the one that really threw a stick in my spokes. Okay, I've been practicing though. I'm ready. Put me in, coach. So, from P to E, I'm going right 7 and then up 10. So this was 10 and this one is 7. I'm going to go down here. So obviously half of the 10 is easy. It's just going to be 5. Half of the 7 is a little bit more exciting. It's just going to be 3.5 to the right from P. So 1, 2, 3.5. And then I'm going to go up my 5. 1, 2, 3, 4, 5. So I'm at the point negative 1.5, negative 3. I did this on purpose so that we could see that this works even if we get some like in-betweeny kind of weirdo points, that life doesn't always just hand us stuff that evenly divides by 2 and 3. Okay? And then I blew it yesterday. So now we know why there aren't more of those on the notes. All right. Any questions about how we found our points, image points? Okay. Go ahead and connect your, oops. Go ahead and connect them. Okay. So, when you're looking at these, okay, never mind. Let's do describing the transformation. So, is this an enlargement or a reduction? Reduction. Okay, and then we're going to practice some function notation because you will need to know that. So this is a dilation. And then we have to specify our center, point P. And then we have to specify our scale factor, 1/2. So this is the entire instructions. So dilate at the center of P with a factor of 1/2, and then we have to say the object of the dilation. So this is the thing that is receiving the action. It's like the direct object of the little math sentence. DEF, triangle DEF. Okay, last bit. What do we know about parallel lines and parallel segments? What's the same about them? They do have the same slope. So when we show it algebraically, it's not enough to just eyeball it. Okay, we're going to have to show it like with a little formula and get our two slopes and show that they are the same. Okay, you guys remember the slope formula? Anybody? Anybody? It's, okay, well, think about it. It's your change in your y's over your change in your x's. So if I told you that I used to weigh 130 pounds and now I weigh 150 pounds, what is my change in weight? 20. How did you get my change in weight? You subtracted. Okay, so when you find a change, a delta, you're looking for a subtraction, a difference. Okay, so it's going to be your ending value minus your starting value. Does this make sense? Okay, so it's the y's on top, your second y minus your first y, divided by your second x minus your first x. Okay, that tells you how did your y change, how did your x change. And if you get a negative change, that means it decreased, right? Mine was not a negative change, and that's why I keep having to buy new pants. Okay. All right, so we are going to find both slopes. So I am going to have to be able to differentiate between my two slopes, so I need a way to label them. A lot of times to keep track of which thing is which, we use a subscript. So if I want to say I want the slope for ED, the segment ED, I can give myself a little ED subscript, and then I don't have to say the slope of ED. It's just, okay, that's obviously which one I'm talking about. A little shortcut. So I need two pretty points on ED. I like these two. Doesn't matter which. So reading from left to right, which one is my ending one? Yeah. All right, so we're going to say the y is 6. And the other y is 4. Would it help if I wrote the points out? Let's do that. All right, so this point is 4, 6. And this point is 3, 4. Okay, this is going to be my x sub 2. This is my y sub 2 because it's my point number 2. This is my x sub 1. This is my y sub 1 because it's my first point. Easy enough? Okay, then I just plug in the stuff I labeled. Okay. So my 6 minus my 4, and then for my x's, it'll be the 4 minus the 3. So 6 minus 4 . 4 minus 3 is 1. That reduces to 2. Okay, now I'm going to find the slope for d prime d prime. Now, do I have to pick this weirdo little point? Can I pick this pretty point? Okay, let's do that one. Let's do these two. So I've got 0, 0. This is my x sub 2, y sub 2. And negative 1, negative 2 is my x sub 1, y sub 1. So I'm doing 0, minus a negative 2. What happens when I do subtracting a negative? Turns into adding. Okay, then same thing for the x's. I'll have 0 minus a negative 1. Turns into adding again. So I get 2 over 1, which is still 2. So I can say that the slope of ED, the segment, is equal to the slope of E prime D prime. Therefore, ED is parallel to E prime D prime. So it's kind of like an informal little proof. It doesn't have like 2 columns or anything, but we've got our algebraic evidence, okay? We've got our statement and then our conclusion. Actually, we kind of used, what is that, substitution? And set them equal to each other, and then our conclusion. Okay, which other ones did I skip? The next one? Okay, J is -3, 0. K, -3, -2. L1, 0. Okay, I've got to dilate this triangle by a factor of 2 with the center of dilation at -5, -2. Can we call that D? Okay, so it doesn't say that I have to do a function rule for the dilation, so I'm interpreting this as what is the coordinate rule. So the x and the y are being transformed. What's happening to them? Yes? Oh, yeah, nope, because I put it in the wrong spot. That's why you're confused. Thank you. Okay, how are we transforming x and y? What are we doing to our coordinates? Yes, we're multiplying by 2. So we're going to double the x. We're going to double the y. This is going to be a much better picture. Okay. Let's just go in order. You want to start with J? So when I'm looking at where my image point is going to land, it's going to have to be on this line somewhere. So here's my J. If I think of this as 1, and it's going down to right 2, I'm going to have to go down to right 2 again and make another one that's congruent. Does everybody see I just doubled it? Okay, if I was multiplying by 3, I would just do that one more time, and I would end up here. Okay? Okay, so I'm going to still put my point in that spot. I'm just cleaning it up so it's not so visually overwhelming. So this is my J prime. All right, let's do the same thing for K. Okay. Looking at my K, I'm calling this my 1. To get to K, I have to go down 4, right 2. So I have to go doubling it, go down 4, right 2 again, and find my K prime. Oops. That's right here. Okay, last but not least. Okay, my 1 is this monster. One of those arbitrary units, lengths, I have to go down 2, right 1, 2, 3, 4, 5, 6. So I'm going to have to go down 2, right 6 again. Okay, and then connect your points. Okay, double check that your sides are parallel. So this slope should be 0, 0, undefined slope, undefined slope. And then this one is going up 1, right 2, up 1, right 2, up 1, right 2, up 1, right 2, up 1, right 2. Okay, let me write down my points. So J prime, I've got it at -1, -2. K prime, -1, is that -6? Please double check me, because I have a feeling still that I just can't be quite trusted today. Just a feeling. 1, 2, 3, 4, 5, 6, 7, and then down 2. 7, 2? -2. -2. Okay, but we're not done yet. The fun's only starting, because we still have to reflect in what line? The x-axis. So the x-axis is this guy. Okay, it is the collection of all the points. Look at this. We got 1, 0. No, that's not 1, 0. What is that? 4, 0? 4, 0. We got 7, 0. What do all of those points have in common? The 0 for which coordinate? The y. So it's a little bit backwards, that's why it's kind of confusing. The x-axis is y equals 0. It's like kind of backwards. So you have to think about it. Okay, so this is y equals 0. So if it's asking you to write the equation, and it's the x-axis, you can't just write x-axis because that's not an equation. I need the line y equals 0. Okay, the y-axis is x equals 0. Right? Okay, rant is over. So when I reflect in the line y equals 0, am I changing my x's at all? Or just my y? Just my y's. So I'm just going to change the signs of my y's. So my reflection rule is x and y map to, keep the same x, change the sign of the y to the opposite of whatever it was. Which is good news for me, because I can just copy down all of my x's. -1, -1, 7. Okay, and then I just make all my y's are going to turn positive. 2, 6, 2. Okay, plot my points. I'll do that in red. Red is a good color. Here's L double prime. Here's J double prime. K double prime. That was kind of fun. Okay. Is that the end? Have we done them all?